Hello and good day. In Algebra, we're covering CO11, going over answers from our homework from the weekend, and then we'll get into CO12 as our objective for today. So last week, I kind of got you started with this. These two absolute value equations in particular, I talked about the fact that you cannot distribute into absolute value bars. Okay, they are strong, right? Like Fortress. So we're looking at this as 6 times n minus 9 equals 18. And remember when we covered the distributive property, if those had been parentheses, and I said, if they were parentheses, we would distribute in the 6. But at that time, I said there are other ways to do this. And so if you go home and your parents or siblings say, why don't you just go like this? We were focusing on the distributive property that day, okay? But who knows the alternative to distributing that we could use in this example here, and we're going to use in our absolute value equation here. Oh yeah, Schleifer.
18 divided by 6.
Right. Since we're multiplying 6 by n minus 9, the opposite of multiplication is division, right? So instead of distributing, we could also divide both sides by 6, essentially cancel that out, and we'd be left with n minus 9 equals 3. And we would solve it from there, okay? We're going to do that here because we can't distribute. So we're kind of locked into dividing both sides by 6 to cancel them out, and we get n minus 9 equals 3. All right? And now that the bars are by themselves, we're thinking about this as the distance of n minus 9 is 3 from 0. The distance of n minus 9 is 3 from 0, which is where our two equations come from, right? Because it turns out there are two numbers that are a distance of 3 from 0. What are they? I'll give you a hint. One of them is 3. 3 and negative 3. So the two equations that we write, the n minus 9 doesn't change, but the value that it can be is different. Because both 3 and negative 3 are a distance of 9 from, or distance of 3 from 0. So in this case, we'd add 9 to both sides, n equals 12. In this case, we add 9 to both sides, n equals 6. And if we plug those values back in, even in just this equation here, if n is 12, 12 minus 9 equals 3. Is the absolute value of 3 3? Yes. 6 minus 9 equals negative 3. Is the absolute value of negative 3 positive 3? Yes. So they both work. Okay. Second one, similar setup. We're going to divide by 2 to start, and that gives us 4n plus 11. The absolute value of that equals 24, which means that 4n plus 11 is a distance of 24 from 0, so it can either equal positive 24 or it can equal negative 24. This one's a little bit messier than the first one. The numbers don't work out evenly, but that's okay because we're in algebra and they won't always do that. 13/4 is one answer, and negative 35/4 is the other. Okay. Questions on those two? No? Very well. All right. So absolute deviation. Same idea as absolute value, only our target number isn't 0. Okay, it's going to be something else. We've got this geometry placement test here. Okay. The target score to get into geometry is 80 with an absolute deviation of 8 points. We talked about this one on the video. So 80 is kind of the middle of the road here. If you score an 80, you'll be average. But you can get 8 points higher than that, or 8 points lower, and still be placed in geometry. If you place with a 72, it might be more of a challenge. If you place with an 88, probably going to be an easier road for you there. But that's the description of 80 points with an absolute deviation of 8. 8 points on either side of 80. Yes, sir? There'd probably be another class, an Algebra 2 class or something there, you know. So on the end of the map test, your RIT score is an absolute deviation of 3. If your RIT score is 230, what is the range of possible RIT scores you're likely to get if you immediately took the test again? So 230 is what you got, but with an absolute deviation of 3, that's 3 points above and 3 points below. So if you took it again, then there you have it. Okay. Professional bowling regulations. We got a bowling pin be 15 inches tall with an absolute deviation of 0.0035 inches. Not a very wide range here, but that makes sense. I mean, if you're bowling, you don't want one pin to be an full inch shorter or 2 inches taller than another. Okay, so our range of bowling pin heights 14.9935 to 15.0035. I put 35. I should put 65. Sorry. 9965. Yes. Happy Halloween. Boo. Questions on that one? Okay. In figure skating competition, a program is 3 minutes and 30 seconds long with an absolute deviation of 9 seconds. So if I'm going to scroll down here so I can write a little bit better. If 330 is your target score with an absolute deviation of 9 seconds, that means to be okay, your program can be 3 minutes and 21 seconds to 3 minutes and 39 seconds. Okay. Anything outside of that range, you're going to lose points for it being too short or lose points for it being too long. So if your routine or if a routine is 3 minutes and 15 seconds long, it's not how far away that is from the 330. It's how far away it is from the 321. Because at 321, you're still okay, right? So it's 6 seconds shorter than 321, so 6 points should be deducted. If you put an answer of 15 points, you are going from the target time, the 330, but remember that the absolute deviation means you're still okay within that given range. So it's how far is it from the low end of that allowed time, right? And then finally, the average amount of time it takes me to drive to work is 24 minutes, 18 seconds. You would not believe the research that went into this. I drove the route 20 times. No, I didn't really do that, but 24 minutes, 18 seconds with an absolute deviation of 53 seconds. If I leave daycare at 6:55, give the range of times you expect to see me trudging in to school. So let's see, where's my answer sheet here? Oh, I even did the work. Where did I do it? What you get is your low end of my earliest arrival time. Anyone confident in their answer? Want to share? Caleb?
About 7:18.
So 7:18. Yes, 7:18 and 25 seconds is the earliest you'd expect me to arrive here, right? What's that? Well, yeah. I mean, if you put 7:18, fine. But since the absolute deviation is in seconds, then you should have that unit there also, right? But the key here was, you had to take that 24 minutes. Maybe I should erase this for now. Take that 24 minutes, right? You had to subtract 53, 24, 18, subtract 53 seconds from that, and then add 53 seconds to that. So if you subtract 53 seconds, it would take me 23 minutes and 25 seconds to drive here. If you add 53 seconds, it takes 25 minutes and 11 seconds. So that's the range of amount of time it's going to take me to drive from daycare to here, right? The shortest is 23:25. The longest is 25:11. Then you had to take the time that I leave, 6:55 in the morning, and then add 23:25 to that. That's where the 7:18:25 comes from as the earliest I could arrive. And then you had to add 25:11 to that, and I came up with 7:20:11. which is about the time that I got here today. Whew. Okay? So it's kind of a two-step thing. First, you had to calculate the shortest and longest times it would take me, and then apply that to the context of the question. All right? What's that?
Was that another time?
It wasn't, but I'll save that one. I'll bank it for later on. Thank you. Okay, anything else? Very well. Onward and forward we go to CO12. It is only one page today, yeah. Yeah. Why? Oh. So CO12 asks us to isolate a variable in a literal equation. A literal equation. And a literal equation is basically a formula. Probably the shortest definition you'll have. Okay? A literal equation is basically a formula. To where, for example, the area of a triangle is base times height divided by 2. The 2 is always a part of it. The base and the height are always needed, and you can combine those things in this manner to find the area. Okay, and so our objective today is, it works great if you know the base and the height, but what if you already know the area and the base and want to find the height? So we're going to be manipulating these formulas to solve for a different value than you typically would. Okay. For example, do I have this one down at the bottom? I don't think I do. So if I know the area of a triangle is 36, and I know that the base of the height of that triangle is 12, and I want to solve for the height. Okay. This would be an example of using that literal equation and isolating a different variable to get the information that we want. I'd still start this by setting up a equals base times height divided by 2, only this time, instead of a being my answer, right? A is 36, the area of the triangle is 36, so 36 will equal my base of 12 times my height divided by 2. Caleb. Oh, very good. How'd you come up with that?
So you times the area by 2 and then divide by the one variable you do know.
Essentially, once you set it up this way, it becomes just opposite operations, right? 36 equals 12 times some number divided by 2. Our first step here would be to multiply both sides by 2 to cancel the denominator of that fraction, which means that 36 times 2 being 72, 72 is equal to 12 times the height. Then divide both sides by 12, and you get the height being 6. Okay, so we're still in the equation realm, but we're applying it to something a little bit different. In this case, formulas to allow us to get a value that we wouldn't always be typically solving for when using that formula. Okay, I didn't leave enough space to really write that and show that out well. My apologies for that, but we'll do a couple of these together so you can see what I mean by this. Okay, so let's scroll down to the first one here. The volume of a cuboid is found by multiplying the length by the width by the height. And you're familiar with this formula: volume equals length times width times height. We write it as base times width times height, but you've seen it in 2 of the 3 math packets that you've had so far, both with a cube and a rectangular prism. But both of those shapes can be lumped together to form a cuboid. Isn't that a great word? Write a formula to solve for the height of the cuboid. What is the height if the volume is 90 cubic inches, the length is 3, and the width is 2. So we're going to start with this formula as it's written here. Volume equals length times width times height. And our first job is to write a formula to solve for the height of a cuboid. So we want to isolate the h variable in this formula. What would we do? We want to get h by itself here. What would we do? James?
Multiply the width times the length.
But if we don't, but right now we haven't read the last question. We don't know what the values are for the length and the width, right? If we did, we would multiply them together and then do what? Then we would take the volume divided by that value, right? But not knowing what those values are, we can't multiply the length and width together, but we can do the second part of what James said, right? James said if we had values here, we'd multiply the length and width together and then divide the volume by that number to get the height by itself. We can still do the second part of that. We can still divide both sides by the length and the width, can't we? Even though we don't have numbers for that. Because if I divide that right side by the length and the width, what cancels out? The length and the width. And I'm left with just the height on the right side of that equation. On the left side, I've got V divided by L times W, which is kind of annoying that I don't know what those actually are. I don't have any numbers to plug in there yet. But if I did, then whenever the length times the width equals, I'm dividing the volume by that amount, which is what James said we were going to do. So the next question here says, what is the height if the volume is 90 inches cubed, the length is 3, and the width is 2? Our volume of 90 divided by our length times our width is going to equal the height. You see how that works? Without the values, I can still represent what I'm going to do, keeping it in variable form. Because once I get values for the length and the width, I'm going to plug those in, and the volume, plug those in, and then solve that equation to equal the height. And what does the height end up being here? Anybody? Or just Caleb? 15, right? 90 divided by 6, the height is going to be 15. All right. The next one, the volume of a triangular prism is length times width and height divided by 3. Write a formula to solve for the length of the prism. What is the length if the volume is 100 cubic yards, the width is 5, and the height is 10? So for starters here, I'm taking this formula and I want to solve it for the height. I want to solve it for the length. So I want to isolate L. So what do I have to do? How do I move the width, the height, and that 3 to the other sides that L is by itself? What would my first step be here? Caleb?
Dividing 100 by 5 times.
Well, we don't know we're not reading past here yet. We're stopping here. We don't have values yet. Okay. What I want to do first, before I start plugging in numbers, that's going to kind of be our way of testing, make sure our formula works. I want to rewrite this formula to solve for h, keeping the volume as v, the length as L, and the width as W. So let's go ahead and actually plug these other things in here. 100 equals 5, or L, I should say. Length comes first. L times 5 times 10 divided by 3. What would my first step be here if I asked you to solve for H? Let's look at it with the numbers plugged in here. What would I do first? I keep saying H, I mean L. what would I do first here to solve for L? Gino? Okay, I'm going to multiply 5 times 10, which will give us 50, right? So I'm just going to erase the 5 and 10 here and put 50. And then what? How do I work to get L by itself? I'm multiplying L by 50 and dividing that by 3. If I want to get L by itself, that means I want to move everything else over to the other side. So using opposite operations here, if I'm multiplying L by 50 and then dividing that by 3, I want to undo that. What would I do first? Multiply both sides by 3, right? Because if 100 equals 50L divided by 3, that means that 50L has to equal 300, right? So that when I divide 50L by 3, I get 100 as my answer. My first step here, I'm going to multiply both sides by 3, and that gives me 300 equals 50L. Over here, I'm going to do the same thing. I'm going to multiply both sides by 3 to say that 3 times the volume equals length times width times height, which is the same thing that I have over here. I multiplied my width and my height to get 50. I'm multiplying that by the length, and 3 times my final volume, 3 times 100, gives me that 300 equals 50L. And then what would I do from there? Going in with the one on the right here, how would I get L by itself? 300 equals 50 times L. How would I get L by itself? Caleb?
Divide 300 divided by 50.
Divide both sides by 50. What in my equation on the left here, 3V equals L times width times height, what equals the 50? What represents the 50 in that equation on the left, that formula? Width times height, right? Remember, I got this 50 by multiplying the width and the height together. So if I'm going to be dividing by 50 to get L by itself, I'm going to be dividing by 50, or how we found 50, dividing by the width and the height to get L by itself here. So all told, in our equation on the right here, 30 divided by 50 equals 6, and that's going to equal the length there in this case. In our literal equation, our formula, 3 times the volume divided by the width and the height will equal the length. So that if you are given a triangular prism and you want to find the length, knowing what the volume and the width and the height are, this is the formula that you could use to solve that. 3V divided by width times height equals the length. Okay? So it's still the same opposite operations concepts that we've been working with, only now we're practicing it with only variables also, right, within a given formula. Let's look at the next one with circles here. The area of a circle is A equals pi r squared. You've seen this several times in math packets also. write a formula to solve for the radius of the circle, and we're stopping there. Okay? We're not looking at the values yet. So we're taking this formula, a equals pi r squared, and we want to solve for r. We want to write the equation that r is by itself. So our first step is to look at what are we doing to r. We're multiplying r by pi, and we're squaring it, right? We're actually squaring r first, following the order of operations, squaring r first, and then multiplying that value by pi. So to undo that and get r by itself, what are we going to need to do here? Work through that order of operations backwards. If to solve the equation, we square r and then multiply by pi, to undo that, we would first we're not going to root first. Remember when we solve an equation for a variable, we work through order of operations backwards? We would do the reverse order, James?
You would divide the area by pi.
We're going to start by dividing both sides by pi to cancel it out from that right side. If we knew what r was, we would square first, right? But if we don't, to undo that, we're going to be dividing by pi first. And that gives us now a divided by pi equals r squared. And here's the first example of why PERMDAS people just have happier lives than PEMDAS people. Because PEMDAS people look at this and say, r squared, how do I undo an exponent? What? I'm lost. I don't know what to do. PERMDAS people, we know how to undo an exponent, don't we? What's the opposite of an exponent? Blake? A root. So to undo this, get r by itself, we're going to root both sides. And so for any given circle, the radius is equal to the square root of the area divided by pi. Okay. We're going to pin this. We're going to pick it up tomorrow, kind of work through the other ones, work through the rest of them together. And so no homework tonight. You do have con due Thursday, so go ahead and start on that tonight. And that is how you math.